Hello and welcome. I'm glad you could join me today for this exciting introduction from Cambium Networks, cnMedusa. My name is Matt Mangriotis. I'm the PMP 450 product line manager, and I'm very excited to introduce cnMedusa today to you. We're going to talk about what it is, how it works, and what it might do for you. And without further ado, let's talk about who Cambium Networks is. Cambium Networks is the industry leader in point-to-multipoint and point-to-point IP wireless solutions. Headquartered in Rolling Meadows, Illinois, which is just west of Chicago, we have major development centers in both the UK and in Bangalore, India. We've shipped more than 5 million nodes to date. We are in thousands of networks around the world. And we've shipped almost 750,000 PMP 450 devices since its launch about 3 years ago. We're uniquely positioned to deliver breakthrough wireless solutions to network operators globally. And we're bringing lots of years of experience and technical innovation to this space. Our value is in connecting the unconnected. We connect people, places, and now things. We have best-in-class resiliency, security, scalability, especially in the PMP 450 platform. And we have affordable solutions. While they might not be the lowest price options on the market, they really are best suited to deliver the best solution to the customer. We bridge hard-to-reach distances, all the way from 2 meters to 245 kilometers. Extremely long links, tough-to-reach links. And now we've introduced the cloud-based management tools for all the devices in the network. To go over our solutions at a high level, we have the point-to-point backhaul layer, which is really innovative and highly performing point-to-point nodes that can bridge long distances at extremely high bandwidths. We move downward in the network to the access layer, a distribution network layer, in the point-to-multipoint product portfolio. And we have secure, reliable, scalable systems to provide that level of technology. And we've most recently introduced the cloud-managed Wi-Fi-based portion of the portfolio to give the access to the end user. Again, walking through the portfolio, we have the long-distance point-to-point in the PTP 650 and PTP 820. Then we move to distribution and access with the PMP 450 and ePMP product lines. And then we can go inside the home or business or local Wi-Fi with the CN Pilot portfolio. All of this can be managed by the CN Maestro management tools, which is a cloud-based service and also soon to be released on-premise version. And we really support an end-to-end fixed wireless solution. Today I'm going to focus on the PMP 450 product line and all of the innovation that's going into that. To summarize the 450, it is the flagship PMP portfolio within the Cambium Networks family. It was designed to increase system capacity. Today we do 125 megabits in a 20 megahertz channel, and we've recently introduced increase to 30 and 40 megahertz channel support, which will bring us above 250 megabits per sector. We can do a lot of bandwidth at a given tower site because of the ability to put multiple radios next to each other, and we have multiple frequencies to be able to use at the same tower site. So whatever density is required, the product can handle it and scale accordingly. It's based on OFDM MIMO technology, which provides a great performance in line of sight and also in near and non-line of sight conditions with certain frequencies. It is truly a software-based radio design, and what that means is because we're built upon an FPGA, we're not constrained by the standards-based ASICs, and we can react to customer requests in a much more efficient manner. We can propagate frequencies and features much more efficiently and quickly. And it's really an advantage and an advantage in flexibility for the evolution of the platform. We've brought forward the ability to do GPS synchronization in the platform. This is a key technological parameter that maximizes spectral efficiency while minimizing self-interference, supporting all the applications that you're used to. VoIP, video, gaming, and we've evolved the platform. We've introduced 450D, 450i, And we continue to evolve. So since launch, we've added more spectrum, more frequency band supports by introducing new hardware. We've added 2.4, 3 gigahertz, and most recently 900 megahertz to the platform. So the 450 now supports just about every unlicensed band in the world, and we've expanded the 5 gigahertz support to include 4.9 as well. It's truly a spectrum agile architecture. We've added modes of modulation to increase throughput. We've added different modulation types to increase link budget where the RF conditions are such that it can't do dual payload modulation. We've improved PPS, especially with the introduction of the 450i platform. We've improved it 3 or 4 times by introducing that platform. And we've increased the MTU size capable so we can support MPLS or VPLS tagged traffic if you so choose to use that in your network. We have a feature-rich QoS system built into the radios, so you don't need expensive routing equipment behind the radios. You can use it right in the radio itself in the link. A typical architecture, and this is the main bread and butter, if you will, of the 450 product line, is the residential application. And what we're doing is it's a very simple, flat architecture. We go from the base station, and we can have multiple access points at the base station, and those can be powered and sync distributed to by the CMM, or the cluster management module. From there, it wirelessly attaches to the customer premise equipment, or the subscriber module, which is located on the customer's home or residence or business. And that a single PoE cable can bring that data and power inside the home to our CN pilot equipment to provide local connectivity for devices internal to the customer residence. Again, very flat network, very simple to deploy, and no extraneous infrastructure equipment needed beyond that. Another key application of the platform is in video surveillance, which requires high uplink ratio. The equipment is fully capable of supporting a high uplink, and with the introduction of the 450i product line, the complementary product line to the portfolio, now we can hook up a PoE camera directly to the subscriber module without introducing a separate power supply. A simple Ethernet cable connects the aux port from the PMP 450i directly to that camera, and now we can provide video uplink through the network. Again, leading radio performance, high security, scalability, a complete wireless solution for video surveillance. Another very common and growing application is carrier Wi-Fi services, or carrier offload. What this really means is that we're taking traffic that would otherwise go over a mobile carrier's network, his mobile network, and moving it to Wi-Fi connected by our fixed wireless solutions. So we take the 450 product, connect the home, residence, business, or campus using 450, and then we have the CN pilot devices to attach those end user clients and offload traffic from the mobile network onto the wireless, the fixed wireless links. A lot of Tier 1, Tier 2 carriers are starting to look at Cambium networks as possibly an option to help alleviate congestion on their network. And again, with the single pane of glass cloud management tools available, this becomes an easier proposition for those guys to integrate. So the 450 really is a globally deployed solution. It's deployed in systems all over the world. It's extremely scalable. I mean, we just had a customer break 100,000 subscribers in their own network. Incredible amount of scalability is built into this platform. North America obviously is the largest center of business for us, and we do a lot of business with this product in Western Europe and throughout the European countries. But we're also seeing uptake from several emerging markets, such as Peru, Mexico, and Latin America, as well as in India. A lot of the governmental services in India are very interested in the 450 and deploying rapidly. And it's a flexible solution. It's not prohibitively expensive, such that a smaller customer may be able to take advantage of this and grow their business using the PMP 450, but it can scale to hundreds of thousands of subscribers. We have several frequencies, or several tools available in the toolbox to support any links that are required, from 900, 2.4, 3 gig, as well as the 5 gigahertz. And we support many different applications. Obviously, residential and enterprise access are the main application, but we also support video surveillance applications, Wi-Fi transport, as I mentioned, and coming soon, the industrial Internet of Things, especially with the 900 megahertz product. That's definitely an option. Network operators around the globe face several challenges, however. Spectrum is becoming more scarce. 5 gigahertz spectrum is the most widely used worldwide, but it's also rapidly decreasing in availability. As you do your spectrum scans, you'll see noise and interference levels increasing all over the place. And you might turn to a license band, such as 3 gigahertz. But the license band in 3 gig, you're not allocated a significant amount of spectrum. Maybe you're limited to a 14 megahertz channel and such. And so really spectrum and the availability of spectrum is a key parameter in your decision on how to solve this, the connectivity problem. As noise floor and interference increases, and it's increasing everywhere, this becomes even more of an issue. So it's really, the network operator has to consider the business case against the revenue per user that he can generate. And so you got to consider not only capital investment in the platform, but also the operating expense and how much it is to deploy this thing. And really what we're doing is ramping the average capacity per served address by introducing this product. I'm going to take a moment here and show a quick video about the evolution and the performance over time of the PMP 450 network.
In 2004, Cambium Networks created an industry. The PMP 100 brought high-speed broadband to places it had never been before, all over the world, wirelessly. As times changed, so did we. A richer, media-oriented internet demanded more bandwidth, and with the PMP 430, we obliged. As YouTube and other video and media services grew, internet service providers were feeling the pinch. With PMP 450, we helped them level up their networks to handle the demand. In 2015, the demand for more bandwidth showed no signs of slowdown, with HD streaming video the new standard for online media. With PMP 450i, internet service providers increased their network capacity by replacing a single piece of hardware. Now, in 2016, with streaming HD video services replacing cable and satellite TV in thousands of homes worldwide, and more connected devices in every home, networks are reaching their limit once again. PMP 450M, powered by cnMedusa technology, puts service providers ahead of the demand, building their network for tomorrow, using their existing subscriber hardware, and the same wireless channel. And this is just the beginning.
So as you can see, our objective here is to go massive. If you haven't been to the website, I would encourage you to check out cambiumnetworks.com, go massive. And why are we talking about going massive now? In the past, you've had to serve many applications with the fixed wireless solution of choice, including Xbox, Netflix, Skype, but there are so many more coming. There's so many more cloud-based services. It's just ever-increasing capacity, demand for capacity. So you think, well, why not just increase the channel size? I mean, there's a lot of manufacturers out here doing point-to-multipoint equipment and offering larger and larger headline throughputs. They talk about 500 megs, 750 megs, even a gigabit per second per sector, but they're doing that with wider channels. You just don't have that kind of spectrum available. So what we're doing, and that's unique to the Cambium entree here, the cnMedusa product is allowing us to provide upwards of 500 megabits per second per sector in the same 20 megahertz channel. That's critical for spectral efficiency and critical for the networks to be able to continue to operate in the way that you are used to. We're not just increasing channel size, but we're pushing more data through the same channel. And can you really afford to do a total network replacement at this time? If you've invested in a platform, wouldn't it be nice to have that same subscriber equipment work with this advanced access point technology, the cnMedusa and 450M? We sure think it'll save you a lot of money in truck rolls and replacement of that customer premise equipment. And that's what we do with cnMedusa. We're increasing capacity for the media-rich applications that are coming down the pike. We can do over 400 megabits in a single sector today, and we have a roadmap that will get us to 1 gigabit per second per sector. And we're doing it all with the same amount of spectrum. We're doing over the 400 megabits in a 20 megahertz channel, which equates to about 20 bits per second per hertz of spectral efficiency. And when you consider this innovative antenna design, we are able to continue to use this frequency reuse pattern in a back-to-back fashion. So I can actually double that spectral efficiency and get to over 40 bits per second per hertz. Incredibly innovative and unheard of in our space. And we're doing this all while protecting your investment in the platform. So if you've purchased PMP 450 equipment up to date, you can continue to use those subscribers with this new technology. You simply replace the access point and you can realize these capacity increases. It is truly groundbreaking innovation in this device. It is truly massive. It's going beyond the standards of the LTE. We're introducing a 14 by 14 antenna array, a massive multi-user MIMO antenna. It's a beamforming sector array antenna system, which eliminates any connections of RF cables. The only cable that you need to connect is that Ethernet cable to provide both power and data. All of the connections between the radio and the antenna are internal to the device. And it'll dramatically lower product cost. It allows us to develop this innovation while keeping that cost reasonable for the consumer. And it reduces installation time and complexity by having everything in one box. The innovation in the antenna array really enables operation in high noise environments with narrower channels and to a higher density of customers. But cnMedusa is more than just a product. It's really the name that we're giving to the technology. The technology that enables us to do 5G-like speeds and capacities and provides us that growth engine, a platform for innovating on. By combining this RF design, the antenna technology, it allows us to unleash this first-of-its-kind, really, performance engine, if you will. The 450M product is the first one that will contain cnMedusa technology, but it won't be the last. We are using this 450M to leverage the 450 platform at this time, but cnMedusa will appear in future products as well, and perhaps on other product lines. So what does the 450M look like? As you can see here, it's about 2 feet wide, 20 inches tall. It's one simple device to install. It contains a 90-degree sector antenna, a beamforming sector array antenna, and it showcases the massive multi-user MIMO, which allows simultaneous connections of up to 7 SMs at any given point in time. And it allows you to achieve supreme spectral efficiency, over 400 megabits in a 20 megahertz channel. I'm going to walk through some of the key system features. It really is combining beamforming and multiple RF chains to yield more than 3 times the amount of throughput versus an existing 450 or 450i sector by simply changing that access point hardware. So for example, if you have a sector that has subscriber modules in varying modes of modulation and you get an average of about 60 or 70 megabits through that sector, by simply changing out the access point hardware to the 450M, you should now realize between 180 and 210 or even more of access point or sector throughput. It is leading edge innovation that brings this smart beamforming to the platform. And there are, again, no RF cables to connect or weatherproof. It eliminates 14 points of failure. Because it's 14 by 14, we can talk to up to 7 subscribers simultaneously. You can realize this capacity increase without any truck rolls to your existing subscriber modules. It's simply a software upgrade, and by the time this product is shipping, which is in September, we will have the software released and available that your subscribers will need to connect to it. And again, there's no reason to replan frequencies. Because we're using the same 20 megahertz channel, you can simply replace the hardware using the same frequency that you were on and not have to change the network at all, but realize the substantial increase in spectral efficiency. We've added a couple of I/O options here. We've added the aux port, replaced the timing port with the aux port, similar to what we did in the 450i. We've also added an SFP port for those that desire optical connectivity as well. And it is a single SKU, a 5 gig SKU that will cover 5150 to 5925 in the same SKU. So all of the 5 gig bands. So what makes up Massive Multi-User MIMO? What is this technology and how does it work? I'm going to go through a little bit about how this is being applied in our product line. It's really building upon subsequent versions of technology that all in combination enable Massive Multi-User MIMO. First, we have multiple input, multiple output, or MIMO technology. We introduced this first on the 450 platform that really multiplies link capacity by allowing more than one antenna polarization to send and receive data. So in a single polarization, we're transmitted, let's say, on the vertical, and we transmit using one transmitter through that vertical polarization antenna, and we get a certain amount of data. In a dual polarization system, or let's say a 2x2 MIMO system, we transmit one set of data using one transmitter on the vertical, and then another set of data on the horizontal polarization. And so I'm now transmitting twice as much data. And if I can decode them at the other end, I've doubled my data rate. So a separate antenna is used for each polarization. And that's MIMO. Now we can multiply that effect by having multiple sets of antennas. Obviously, when you do that, the complexity gets much more complex, much more rapidly. And so we can describe systems such as the internal Wi-Fi systems, the indoor Wi-Fi systems that are out there today that are employing things like 3x3, 4x4, up to 8x8. And anything beyond 8x8 systems today is considered massive MIMO. And because we're employing a 14x14, we're calling ourselves, the 450M, massive MIMO product. MIMO techniques, though, are really designed to improve data throughputs between two nodes, in one link. But what we're doing is adding, on top of that, the multi-user capability, or a multi-user MIMO. And this allows communication between multiple nodes at the same point in time. The AP communicates to multiple subscribers across that sector, and it's done via what we call spatial multiplexing, which requires spatial diversity between subscribers. Spatial multiplexing really means you're transmitting data and you're able to transmit an integral signal that can be decoded at the other end because I have separation between those subscribers. It works most efficiently the wider or the more separation there is between them. What cnMedusa is doing is actually creating groups of SMs on the fly, or every TDD frame. It creates these groups by determining which subscribers within that sector can be spatially multiplexed. The minimum separation is about 6.5 degrees, and this grouping algorithm does run every frame. So you can see in the little picture on the slide, we have multiple subscribers across that sector, and we're able to group a few of them together at any given time slot to talk to more than one simultaneously. Now, how does the radio know how to do this? To operate in multi-user MIMO systems, it has to know what we call the channel state information. And it gathers this information by doing a process called sounding. The cnMedusa periodically collects this channel state information from all the SMs within that sector to evaluate the conditions of the channel and determine if it's eligible for multi-user grouping and which kind of weights it's going to give to those subscribers within the group. So this process occurs regularly and allows it to group the various subscribers together to achieve this simultaneous communication. So I'm going to talk a little bit about the antenna array. In a conventional system, the static sector antenna provides a wide beam, a 90-degree or 120-degree sector. And what we're doing with beamforming, the beamforming antenna array that we have, is narrowing that beam and steering it toward a specific subscriber of interest. And in advanced systems like this one, these beams are moved between these subscribers. So in sector mode, we're talking sequentially, one at a time, to each subscriber in that wide area. But in beamforming mode, now we talk to one subscriber, but we've adjusted that beam of antenna to effectively talk to only that subscriber at any given point in time. And at this, to build upon the MU-MIMO operation, this is the sequence of events that takes place. The access point actually identifies which subscribers are connected in the sector, and it collects sounding information from each one. And then the array forms this narrow beam to the subscriber of interest and transmits and receives data. Now the multi-user aspect is that this can all occur simultaneously. So now we'll show a short animation that kind of explains this process. So how does massive multi-user MIMO work? An access point's deployed, and subscribers are located across that sector. And in a conventional system, the sector array antenna talks to each one simultaneously, or in sequence rather. And with a multi-user MIMO system, a massive multi-user MIMO system like we have up to 7 simultaneous transmissions. So these beams are formed at the same time to different subscribers within the network, and they're all talked to simultaneously. A key aspect of the launch of cnMedusa that goes along with this is the support of 450M in LINKPlanner. This is going to be deployed very shortly, a version of LINKPlanner that supports 450M modeling. LINKPlanner, for those that don't know, is a tool that we've offered free of charge for many years. It's been used historically to plot and plan links for the PTP products. And most recently, about a year and a half or so ago, we've introduced the ability to plot PMP networks within LINKPlanner as well. And now we will support the 450M. So you can actually go into LINKPlanner, plan your deployment or input your existing deployment of a 450 sector with all the locations of all the subscribers, and then swap the access point equipment virtually within the LINKPlanner tool to see the capacity, the expected capacity increase. Pretty impressive and powerful tool for helping to plan your migration towards higher capacity. So as you can see, you choose the 450M product line from the product side, and then you change modes from sector mode to multi-user MIMO mode, and you'll actually see the change. In this example that I'm showing, I have a sector of 111 subscribers, all in various modes of modulation, and my total downlink throughput is about 33 megabits. Now I make that change, I swap out my access point for a 450M from the 450, and I can see my downlink throughput move from the 33 megabits of capacity to almost 109 megabits of capacity. Total throughput goes from about 45 to 145. Very impressive increase by simply changing that access point. You may also notice that the uplink modulations in the center of each table got better when going to the 450M. And this is due to the receive beamforming capabilities of the antenna array system, which is inherent in the cnMedusa product. So where are we headed from here? We are currently, in the bottom row of this chart, doing about 125 megabits in a 20 megahertz channel. We're introducing now the 30 and 40 megahertz channel bandwidth, so we are increasing the ability to support wider channels. We think 40 is about as big as realistically expected in the unlicensed space to be able to operate in. But we'll be able to achieve about 250 megs using a 40 meg channel. And now, with the introduction of cnMedusa and the 450M, this massive multi-user MIMO architecture, we expect to be able to support upwards of 400 megs today. And building upon that architecture, we will be able to support wider channels with the Medusa product. We will be able to do other things, improving technology in the antenna systems, second generation higher order multi-user MIMO, and improving and iterating on this technology to get well above a gigabit per second per sector. It's really designed for the future and optimized for the total cost of ownership of the operator. It will scale in this hardware. It will scale to 40 megahertz operation. We are future-proofing the platform because we have a very beefy, a very high-end FPGA, and it's a quad-core system on a chip, if you will, processor. It really extends the life of the existing 450 subscriber modules and will support future generations of those modules of the 450 platform devices. We are planning on introducing a new subscriber module into the platform early next year that will improve speeds on the subscriber side. And we have a commitment to address the 3 gigahertz next with cnMedusa. So we are planning on introducing a 450M in 3 gigahertz as well next year. And we have a lot of ideas and a lot of things in the roadmap to improve this technology as we move forward. One of the key aspects of the LTE standards technology is what they call channel aggregation, which is taking multiple discontiguous channels and using them in conjunction with each other to multiply the capacity. We are planning to be able to support that sort of activity with the Medusa product. We see this capacity increasing beyond 750 megabits per second per sector pretty soon after launch. And we'll work on getting higher order MU-MIMO. We're going to reuse this architecture moving forward and support new frequencies, maybe new antenna systems, and continue to improve the packet per second capabilities and get that throughput up beyond a gigabit. So to summarize, the 450M will be shipping in volume in September. Now we're launching it today, we're announcing it today, we're excited to do that. We have it in engineering trials now. We're going to open it up to some beta trials down the road, and we will be shipping in September. It is a 14 by 14 massive multi-user MIMO capable of talking to up to 7 subscribers at any given point in time. It's unprecedented spectral efficiency in our space, achieving over 40 bits per second per hertz in a 20 megahertz channel, 400 megs in a 20 megahertz channel. It requires no evolved packet core, no EPC, no gateways, no licensing for SIMs. There's really no additional requirements or cost associated with these improved capacities. That integrated antenna system reduces capital and operating expense. It eliminates points of failure. It makes it just as simple to install as our current equipment. And really higher user capacity at higher data rates than any comparable solution in the industry. So with that, I'd like to open it up for questions, and actually some questions have come in, and I'd like to answer them right now. And if we don't get to any questions that you may have, feel free to type them in the comment box below the video. And if we don't get to them today, I encourage you to go to the Cambium Network's community forum and post your questions there. We're always active. I'm on there all the time, as well as all the engineering community. So I'd invite you to do that. But I'm going to go through a couple of questions that we've got already. In what way is Medusa a revolutionary technology? That's a very good question, and I think I've summarized that a little bit, but it's really about the innovation in combining the multiple MIMO techniques with the sector beamforming array antenna that'll provide you with that enhanced capacity. Now, it's not the most capacity, it's not the highest number you'll ever hear, 400 megs, 500 megs, but doing it in the package at the affordable prices in your own network without replacing equipment, that's where the revolution comes in. What is the price? That's a simple question to answer. Me as the product manager, I always talk about prices in terms of MSRP, and the MSRP, or the suggested retail price of this product, is $6,995. May sound like a lot. It's only about twice the amount that you'd pay for an existing 450, but as I mentioned, the average, or in a typical sector, you'll be enjoying 3 times the amount of capacity. So if you put it in that perspective, maybe it's a little more affordable. How many CPEs or how many subscribers can a sector support? It's the same as our existing 450 line, meaning I can support up to 238 subscribers per sector. That number does not change whether you're using 450, 450i, or cnMedusa with 450M. What is a typical area where Medusa will be deployed? Another good question. This product is not for every sector or every network. Really, it's designed to increase capacity where capacity is needed. Now, you might say, well, I need capacity everywhere. Well, if you're not able to take advantage of the spatial diversity of your subscribers, let's say you're shooting down into a valley and all your subscribers, all the homes are in a row, and they're all lined up in relation to that access point. You're not really going to take advantage of the multi-user capabilities. The spatial diversity is not there to support it. So you probably wouldn't invest in a 450M in that location. But with a typical deployment, typical density with some spatial diversity, you can expect to achieve about 3 times the throughput in a given sector. This all sounds very complicated. Can a WISP really install and manage this device and this system? Absolutely. So one of the other hallmarks or beauties of what's going on here, the evolution of this platform, is just that. It's not something new. It's not something unknown. All of the technology and innovation that goes into it is really in the engineering of it and behind the scenes. What it appears in the user interface, cnMaestro, everything is the same as the existing 450 platform. So if you've used 450, you like 450, it'll look exactly the same to you. There's really nothing different that needs to occur from installation all the way to operation. It's almost identical, but you're enjoying the benefit of this capacity increase and spectral efficiency increase. Is there a connectorized version available? No, there is not, and there's no plans to develop a connectorized version. Again, a lot of the innovation went into connecting this sector array antenna to the radios themselves, and we actually have several patents on that technology, and really that is what's both saving the capital expenditure. If we did a system with a separate antenna and multiple RF cables, the whole thing, putting it up all the way to the capital expense of the equipment itself, would be increased dramatically. So no, there's no connectorized version. And what about other sector sizes? You talk about a 90-degree sector. We don't have plans today to do different sectors. We're sticking with the 90. It's a 90-degree 3 dB roll-off, so it's a true 90-degree sector. But it does, you'll see in the pattern, when the pattern gets published, that it's actually a 6 dB roll-off at 120 degrees. So you can support an even wider sector. And in our engineering trials so far, we have some, one of the sectors that we're in right now actually has some subscribers that are beyond that 90-degree sector and are operating just as efficiently and well towards that edge. So we support 90, and we support the AB frequency reuse pattern in the 90-degree sector, but we will also support, with that same antenna, a 120-degree sector. And then the last question I have that has been handed to me is, do you plan to support other bands than 5 gigahertz? And the answer is yes. I alluded to it in the last slide, but we are planning and committed to supporting the 3 gigahertz space as well. It may look a little different size-wise simply due to the physics of the antenna system, but we are replicating this architecture moving forward and embedding cnMedusa in the 3 gigahertz space as well. And we'll plan on doing other frequencies as they become market opportunities for us. So with that, again, I'd like to summarize and say, if I didn't get to your question, I know there's probably some out there, I would encourage you to go to the Cambium community forum, post the question there. We'll be sure to answer it there. And I thank you all for joining. I appreciate your time. Thanks very much.